So now for our fourth video, let's talk a little bit about the regional differences between the vertebrae. We just talked about what like a general all-purpose generic vertebrae would look like what kind of features they all have. Now we're going to go into what makes a cervical vertebrae, a thoracic, a lumbar, and the sacral vertebrae. So the cervical vertebrae have like a pretty unusual shape even compared to the other areas. The thoracic and the lumbar vertebrae arguably have a little bit more in common shape-wise than the cervical ones do to either of those two other regions. So the first really notable difference is that the body of the vertebrae takes up a lot less space and is substantially thinner than the bodies of the vertebrae anywhere else. So smaller and thinner, okay? They're going to stack one on top of each other a little bit more tightly as well, sort of as a result. The reason that the bodies of those vertebrae are so much smaller is because they don't really bear much weight. If you look at this picture of the spine up at the top here, you can see that the bodies of the vertebrae are much, much smaller in the cervical region than in the lumbar region. And in fact, you can see a pretty clean gradient where they start off very, very large and they end up very, very small the higher up you go. This is what's bearing all of your weight. The arch and the processes of your spine bear no weight. It's all taken up in the bodies of your vertebrae. And in fact, the rest of your weight sort of depends, all the rest of your body weight depends on those sort of stacking neatly on top of each other and being capable of carrying all of the weight above it. Okay? So your cervical vertebrae are very small and very thin because truly the only thing that they are capable of holding up is your head. For those of you who do stuff like yoga and you do like headstands and stuff, when you have your weight on your head, you will hear all sorts of mumbo jumbo. I do a lot of yoga. So you're gonna hear all sorts of mumbo jumbo about like how to train your neck to be stronger, to support your weight of in your handstand or your headstands, and certain curves that you should be able to do when you're up there. Just don't take it super easy. Keep as much weight off of that as you can because your cervical vertebrae are not capable of bearing much more weight than your head itself, and your muscles only contract. They don't extend, right? So they can't actually brace you much against that force. Okay, I'll get off my soapbox for a minute. So you have the bodies of the vertebrae that are very small and very thin. Your spinous processes are bifid, B-I-F-I-D, which means instead of being one point like we saw before, you have this sort of V shape to them. These actually have this sort of like V, like non-one point characteristic because it's a developmental thing. So they develop from two secondary ossification centers instead of just the one. And you find it everywhere between C2 and C6. C7 has one like discrete point. And in fact, if you reach down into your lower neck, so where your lower neck meets your upper back, if I can just speak colloquially for a minute, and there's that one extra pointy spinous process, that's your C7. So that's clearly making just the one point. And then Atlas doesn't really have meaningfully a spinous process. So I guess in the last video when I said that everything has a spinous process, it was kind of a lie. Atlas doesn't really have it. Anyway, those also help form an attachment point for the nuchal ligament and for some of your deep extensor muscles as well. So your spinous process is bifid, mostly. Your transverse processes aren't just like single spokey, pointy outy things, just like the rest of your vertebrae so much anymore either. Instead, here you have transverse foramina. And these transverse foramina is where your vertebral arteries go. So we saw in a video a couple back when we were talking about general attributes of the spine and the vertebrae and their blood supply. You have this branch coming off of your subclavian artery that goes and like threads itself up through your vertebrae. They're going up through your transverse foramina. Ultimately, they're going to merge and then they're going to become part of your circle of Willis. So those puppies are going straight up to your brain through your cervical vertebrae. Another reason to take care of your neck, protect your neck. Transverse foramen for vertebral. arteries. Okay, we have two special cervical vertebrae. We have atlas and we have axis. One of them is C1 and one of them is C2. Atlas is C1. Atlas in, what is it, Greek mythology? Now watch, it's Roman, but I'm pretty sure it's Greek. Atlas holds up the world, right? So Atlas will hold the weight of the world on his shoulders. Atlas, the bone, is holding the weight of your head up on its superior articular facets. These superior articular facets are what's going to form a joint with the occipital condyles of the occipital bone on either side of your foramen magnum. And this vertebral foramen right here is continuous effectively with your foramen magnum in your skull. Okay, so this is top of spine, below occipital bone. Does it have a body? Not really, kind of. I mean, if you look at it, you have these two articular processes. You have this vertebral foramen. You've got like a hole kind of where you would think of as having a body of your vertebrae, but instead you have the dens of axis, which I'll get to in a second, there instead. So you don't really have a body of a vertebrae, really. You do have sort of a ligament that cuts across right here. And so that sort of helps hold that dens in place and helps it form like a mobile body-ish structure, but it is not technically a body. And then finally, your spinous process. Atlas doesn't really have a spinous process either. So this is just sort of like a ring, right? With a couple of cups on top to hold up your head. Instead, what you have is this posterior arch with like a little bit of a bump at the tippy tip there. And that's analogous to the arch of a regular vertebra. And that bump is really kind of where your spinous process would be, except it's not really all that big and it's not even really palpable in a lot of bones. So it's just like, it doesn't have a spinous process. Axis then is C2. That's the second vertebrae. This is directly inferior / part of, and I'll put that in quotes, atlas. So if you look at atlas, it's really just like this ring with these articular facets, right? And that's where your occipital condyles go. Now, if you think about how that's going to be resting up against your skull and the shape, those like saddle shape to your, these take on a saddle shape and they sort of seat those convex curved condyles. This is what permits you to make like a yes movement with your head without moving any other part of your neck. It permits that kind of movement and it's just sliding along in that joint. Axis has to stick up into atlas and provide a means along which atlas can pivot right and left. Okay? Your head goes up and down, yes and no, against atlas without atlas moving. Atlas, the dens, this pointy uppy part right here that you can see right here in the middle, is going to stick up into atlas to permit atlas to also then rotate side to side while it's keeping your head otherwise in place. So it's not actually part of atlas, but the two really need each other in order to be able to let your head move around the way you want it to move. Oh, I'll point out too, and this is something that frustrates me a little bit with every medical image I've ever seen, but a lot of times you're going to see your vertebrae positioned like this, where this is posterior. But in atlas and axis, a lot of the time, this is posterior. Fun, right? So this area, let me actually change the color here real quick. So this area is sort of like body-ish area, and this is also sort of body of the vertebrae-ish area. That's fun, right? Anyway, so this is inferior to atlas. It's very much like a functional part of how atlas is able to do its thing. Axis also doesn't really have a body, although it kind of does have one, sort of like this part under here. Oh no, my pen doesn't work anymore. Here we are. Let's try and make that work. Nope. Okay, so we're not going to work anymore for just a minute. Oh, there we are. That's okay. So it's going to be kind of underneath the dens, but it's not robust the way you think of other vertebral bodies as being. So mini-ish. Spinous process, you do have one, but it is also still bifid. Okay. And then your funky add-on is the dens. And again, that is the part that I just pointed out that allows Atlas to rotate right and left along axis. So axis is not moving, Atlas is moving right and left along it. If Atlas doesn't move, then all you can do is up and down with the occipital condyles, yes and no. All right, so moving on to our thoracic vertebrae. We don't have nearly as many modifications here or in the lumbar vertebrae as we do up in the cervical area. That's all like all special sauce all day long. This is a lot more like what you think of as a typical vertebra. So your thoracic vertebrae are all sort of in this kyphosed convex curve of your spine. The bodies are a bit larger and thicker than cervical. And why? Because they have to carry more weight, right? So they're a little further down. They don't just have to carry the weight of your head. They have to carry the weight of your head and all the cervical vertebrae and everything in your thorax and your upper limbs. So these have to be quite a bit more robust. And you can see that they grow dramatically in size the lower you get up between T1, which is sort of like this size according to the picture, and T12, which is more like that. Quite a bit of a difference. The spinous process right there and right here is very long, narrow, and points down. So if you think back to the very first, like the intro slide that's all blue with the person doing a back bend, go back and take a look at that for a minute. And that's going to show you what that downward facing spinous process is able to accomplish. Alongside all your superior articular facets, your inferior articular facets, the stacking of your vertebrae, which is a flat surface up on top of each other that permits only so much curvature in the first place and so much movement in the first place. You also have this downward pointing spinous process. And so if you think about how you're going to be able to bend, that's going to permit you to bend pretty far forward, just thinking about just by virtue of the spinous process. You're going to be able to bend pretty far forward. But when you bend backwards, you can really only bend through your thoracic spine so much. When you do a full back bend, all of that curvature past a certain very limited point is going to be coming from your cervical vertebrae and your lumbar vertebrae. You cannot back bend past a straight line your thoracic spine. And it's because these guys are going to end up being, when you start to back bend too much, they're going to be pointed more downwards, right? So like here's your spinous process as part of back bend. It's going to be pointed downwards and it can't go any further in, right? Go back and look at that picture. You can see their thoracic spine is like straight and narrow. Now, why do you want that there? You really want a lot of flexibility in your spine, right? So like why you would have this extra limiting thing doesn't make a ton of sense intuitively, but that's only until you remember that you've got like a heart and lungs and a rib cage attached here. And so when you back bend, if you have too much range of motion here, you risk sort of pulling things in ways where they won't work so well anymore. So a little bit more of a limited range of motion in your thoracic spine is a good thing. Your transverse processes are also long and narrow. And these are sort of anteriorly pointed a little bit. Ish. Sort of anteriorly pointed. It's like a 45-degree angle, kind of. Now, the thoracic vertebrae have their own unique facets that the other vertebrae don't have. Your cervical doesn't have this, and your lumbar doesn't have this. And those are your costal facets. Remember, your costovertebral joints are all found in the thoracic spine. So you're going to need to be able to form joints with the ribs, and those are going to have their own sort of smooth areas, just like every other joint in your body has like a smooth area and then a bulgy area. So in here, you have a superior costal facet, an inferior costal facet, and a transverse costal facet. Here, you should be able to see where the rib is going to form those joints with the costal facets. So right here on the body of the vertebrae was your inferior costal facet. Up through here in the vertebra below it was the superior costal facet. And here in the transverse process is your transverse costal facet. You have the tubercle, that bumpy area of one of your ribs, sitting in the transverse, and then you have the head and neck of the rib forming a joint with the body of those thoracic vertebrae. So these are your unique structures to identify a thoracic vertebrae from the other regions. You've got the super long downward pointy kind of spinous process. You've got the transverse processes, which have a facet joint on them. And then you have those two other costal facets on the body of the vertebrae, the superior and the inferior costal facets. In addition, I also just think that these look sort of like a giraffe, and that's how I can tell them apart. There's their cute little ears and their long nose, but you know, that's just me. All right, so we're getting on down there. Let's talk about our lumbar spine, the part of our spine that causes us seemingly the most trouble for so many of us. So our lumbar spine is these bottom 5 vertebrae, and they're not fused to one another, right? Nor are they fused to the sacrum, okay? The sacral bones are fused to one another, but they are not fused to L5. So the bodies of these vertebrae are big, thick, weight-bearing, in really big ways. So look how big these things are, right? You have a body of a vertebra in the lumbar area that, there we go, it's kind of like that. And then these ones all the way up in the cervical area are itty, itty, bitty. These are bearing basically the entire weight of your body north of your legs. Okay, so they have to be very, very large. The intervertebral discs are also going to be thicker down here than other parts of your spine. As the bodies of the vertebrae get bigger, not only is the diameter of those intervertebral discs going to be bigger because they have to fit between those bodies of the vertebrae completely, but they're also going to be thicker because they too are bearing more weight. So even though you only have 5 vertebrae in this area, it still is a fairly good bit of the length of your thoracic spine as well. Okay, the bodies are bigger and those intervertebral discs are bigger. The spinal processes are broad and flat. I think of these as looking more like moose. If the thoracic ones look like giraffes, these look like moose. The transverse processes are also blunt. And costal facets are non-existent because that was only in thoracic vertebrae, right? These are as close as, like, whenever you see a quote unquote typical example vertebrae that's supposed to be a catch-all, you're probably looking at a thoracic vertebrae. This doesn't really have many modifications of its own, except for those gigantic bodies and the gigantic intervertebral discs that are really just there to carry weight. All right, so home stretch here now, actually, for realsies, sacrum and coccyx. So your sacrum is 5 vertebrae fused into one. When you were a baby, they were 5 separate vertebrae entirely. Now that you're an adult, they are one sort of mega vertebrae that's sort of morphed into this stingray-ish looking thing. But instead of thinking of it as one big stingray looking bone, instead, if you think of it as sort of 5 bones that all have like a sheet wrapped around them together, this starts to make a little bit more sense. So first of all, your sacrum forms a joint with L5 up here and with your pelvis on the sides. So there, and on this flat, well, flat-ish rough area. Those are called your auricular surface. And those form the joint with your ilium. The bodies of the sacral vertebrae are still actually called sacral bodies. They're right here, right smack down the middle, and they're curvy and everything from the anterior view, just like you would expect of 5 vertebrae stacked up on top of each other. Okay? From the posterior view, you can see where you would have had your spinous processes, and you're actually missing one, kind of. It's actually split into 2, which we'll get back to later. And then they are sort of linked up and make like one long ridge instead of 5 discrete points. And that is called your median sacral crest. Similarly, your transverse processes form a ridge to either side, and that's your lateral sacral crest. Your vertebral canal, I'm going to switch colors for a hot second, but to make it just a skosh easier to see because it's not clearly drawn on this picture. But if you think of this right here as being like the lip, the anterior lip of the sacrum, and then this all is a hollow space in here and down in between, and then out from here is your sacral canal. This is where some of those nerves hanging off the bottom of your spinal cord, part of your cauda equina, are going to be coming through. Okay, so this is analogous to your vertebral foramina, only it's fused bones, so it's one long canal. It's your sacral canal. Finally, your intervertebral foramina are these holes off to the sides. Just like they're holes off to the sides, but in between other vertebrae. And you can even see it still sort of takes on the same relationship to the bodies of the vertebrae. So like where you would ordinarily have like transverse process here and here and here and here, if it were a different kind of bone and you would form a hole in between, it's still just right there. So those are your those are your intervertebral foramina of the sacrum. Okay? You have 2 special features, and I need to erase some stuff to really be able to show you just some of the stuff up top here. All right, so you have a sacral promontory that is going to be this sort of ridge area over here where it's all sticking up. And then you have your superior articular processes as well. And those are these bumps right there. And these form facet joints with L5. Okay? Finally, your coccyx. Again, this was 4 bones when you were a baby, but they are 1 bone now. They are fused. I'm not going to talk a whole lot about these because they don't really do a whole lot. They are the inferior most bones. They are not at all weight bearing, which is partly why if you sit on them too hard, you're going to break this pretty easily. They are angled differently in males versus females, biological males versus biological females. So in females, that will point a little bit more inferiorly, and in males, it'll point a little bit more anteriorly. And if you think about how a baby's head's going to have to come out of there, you don't want it scraping along the bottom of your coccyx. It helps if it's pointing straight down for biological females. That's the end of this one, now that we're at the end of the spine, and so we will move on.